Hey everybody, this is Jan, and in this video we're gonna have a look at text debugging. We're gonna be using the same board as in the previous videos. It is little Nucleo STM32 board, and we're also gonna be continuing with our little project we made in the last video. It is the minimal CMSIS project. Okay, well let's start. Just as a thing we wouldn't have to do, but I would like to do, so we just clean this bit up. Let's move this LED functionality into a different file. So let's make a source file, led.c, header file, led.h, and clean this up. And let's make it LED init, where we enable the peripheral clock and set it as an output, and LED on, where we turn the LED on. Okay, let's copy those two, put them in led.c. Let's include led.h and put some stuff in here. Okay, so this is empty. Let's take it from here. So those two bits enable the GPIOA clock and set the pin 5 to be an output, which is our LED pin. So let's put it in here. And this is the bit which turns the LED on, or sets the output high. So let's put it in here. You can see this is not recognized. We have to include the STM32 file as well. So let's include that. And in our main, let's include the led.h. And we can do LED init and LED on. Okay. Let me just quickly try this. Okay, that's good. Sorry, I don't have the board on the video at the moment. You did see it in the last video. Feel free to try it on your device. This is just to clean it up. Okay, about the text debugging, there is a functionality called ITM, which I'm not sure what that actually stands for. Let's have a look. Okay. Right, that's what it means supposedly. Well, let's have a look at how it works actually. If you start typing ITM and do your control spacebar to autocomplete, you will see a few options over here, and what we want to do is send char. So in this way you can send a single character through the ITM channel. There is a setting to this in the J-Link plugin. If we go into our debug configuration and open minimal debug, which is our debug configuration for the debug mode, which is what we're running at the moment. Let's go there again. And so here we go. Under debugger, it's not here, it's under startup. What we're using is serial wire output as WO, which is enabled by default. If you hover your mouse over this, you will see the information. You can see that you can actually input your CPU clock, or if you put a 0 into it, it will, come back in. No, it says it will be measured by J-Link. So 0 is almost like an auto selection, which will be done automatically, and as the SWO frequency, which is the debugging channel. It says the 0 is almost automatic as well, but you could put your own frequency as well. You could try if you did have any problems. So this is pretty much set up by default, but if you do have a look on yours, just to make sure it does work. Before I debug, let me just put this thing here. This is a no instruction. It doesn't do anything. It's just if I'm gonna step through the code, I don't want to step into the while loop, so I'm just gonna put this behind here. So you know, when I step over things, I have somewhere to rest. Okay, so if we run this, and I'm gonna step through things, I'm gonna get in here. If I click that, you can actually see we've printed A in our terminal or console, whatever you want to call it. So this is your basic text debugging. Once you have this functionality, I'm sure you would know how to debug strings and stuff like that. Even this is not the best thing to send value through, but it's great for basic text debugging. Okay, so let's, if we did, if I do that, and just run it, you will see we've got ABC. If you want to do, you can go and put a new line in there as well, and C, D, E, F. Right, that's really interesting, that is. Hold on. Okay. Let's run again. So you see we got ABC on one line. This is a new line character. So DEF, and our theoretical cursor is on next line now. Okay, so you can use this, but what you probably would want to use is Printf, which is what people normally use. Okay, right. If I try to use this, it's gonna go implicit declaration. It doesn't understand what printf is. Let me close this. What I'd like to use is a CPP reference. It's for C++, but it's for C as well. Printf. If you don't know which headers you need to include, this is the best place to look it up. So you can see actually we need standard.io.h. So let's copy that. And include standard.io.h. If I build, then we know what printf is, but we have some other problems. Sorry. You can see we have undefined reference to, you know, all those functions over here. And what they are system calls. So normally if you was running C on your, you know, operating system, that's what the operating system would implement. This as a minimal compiler and a minimal library, this is actually using newlib, is available to use as well with the default values, which actually don't do anything, but it's by default is set up for you to implement those. Why we actually need those, like this one, is used, you actually need those to do memory allocation. When you run printf, you need to allocate memory, and that's where those are missing, because the program doesn't know how to allocate memory. Okay, the easiest way to go around this is to go into the STM32 Cube folders. We don't have to run STM32 Cube, but if I go into here, STM32, this is where I installed my STM32 Cube, and this is my Cube libraries for L1 series over here. So I can go here, and the file you're looking for is pretty much called the same way everywhere I've seen it. It's syscalls.c. We want to be searching in this folder over here. And you can see there is few, and they are pretty much the same. The only issue is, you can see down here in the bottom, this one was made for True Studio, which has the annoying copyright thing, so we shouldn't be using that one. If you do look for the one which is the SW4, which again, it doesn't have that problem. Let's copy this file and put it in our SIS source folder. Let's paste it here and have a look at it. You can see there's a lot of stuff, but it does implement the functions we were missing, like this one, and there is a bunch of other stuff as well. This is a bit messy, and there is a few things we don't need. We're definitely not running FreeRTOS, so let's comment this out. We can comment this out as well, and okay. We can do write. Let's uncomment this as well. Right, if I try to build now, there is a bunch of warnings. Implicit declaration of abort, so we don't understand this one. Sorry, let me comment this one back out. Unused, 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 unused. So they all seem to be warnings, which we will go. I hate warnings, so we'll go and fix them later. But by putting this file into your project, you can do memory allocation and you can do printf. So let's have a quick look if that actually works. So we run this. I'm just going to run it. And we don't have it. Okay, so there is other stuff missing, which I have forgotten about. Right, if we go into our system calls, what printf is using in the background is, where is it? Is dash write, which is internally using io put char, which is like a generic function. And you will actually see there's almost like a prototype for it, what we need to implement to actually implement the functionality of putting the char in so we can use the write function and the printf function as well. So I'll actually do it here on the bottom. Right, so pretty much what we need to do is return. One thing we have to include is the STM32 header, so we get access to the ITM function, which is actually what we need to call internally to make this work. So let me put this in here. And okay, well, sorry what I did there. Okay, ITM send char. Okay, so this gets passed in here. We pass it in there, and that means we can actually send it here in the really simple description. Okay, so that seems to be building, and let's try again. So let me run it, and run it. Okay, and you can see we have our hello, which is great because that's what most people do use. And let me just get rid of this at the moment. Let's use it somewhere where it makes more sense. Printf. Let's print the system core clock. So we go system core clock, and it is the long unsigned. The value of it is, sorry, if you go in here, I'll show you. Where is it? System core clock is unsigned inth. So that's why we use long unsigned. System core clock. Let's put the new line. If you forget new line, sometimes it wouldn't print until you get the next character or something else. So you might be thinking, oh, this doesn't work. Always put a new line at the end just to make sure it gets here. Let's build. Oh, actually. Okay, let's run it. And run it. Sorry. Right, then you can see we have actually printed out our system core clock over here. So this is really, really, really handy for any kind of debugging. Okay, so this is pretty much the basic functionality. What I'm going to do now is I'm going to clean up this. Sorry, if I go project and clean, which is going to clean the project and rebuild it, you will see how many warnings we have. Normally what I'd like to have, I don't like to have any warnings. So I'm just going to clean it up. I'm not going to show anything new, so feel free to skip the end of the video. But if you want me to watch me fix warnings, then feel free. Okay. Right. Unused variable min stack pointer. Okay. What I do for unused stuff is to cast it to void. Right, so if we rebuild, it goes away. This one is unused parameter TP. Oh, one thing which is handy is the normally format differently. In Eclipse, you can go source format, and you can go whole file, and it formats everything into the, so everything is the same. I prefer this this bracketing than the other one. Okay, let's what's the TP? Okay, so that's great. Okay, the same here. Let's clean it up again. Okay. Oh, PID as well. PID. File. Okay. File again. Oops. Okay. File again. Oops. Copy, paste, file. Well, it's all of those, I guess. File, pointer in there. File over here as well. Oh man, there's so much stuff. Okay, let's try. Okay, almost there. You can actually see the syscall, the printf doesn't use all of those syscalls, but they might be used for some other stuff later on. So I'm not gonna get rid of any of them. I'm gonna keep them all. Just make sure I don't have any warnings, because that would confuse me later then. Yeah. Okay. File. File. Old new. Old new. I'm sure there's a better way to deal with this. This is my stupid way of dealing with this. Name. Hardware. Okay. So let me clean again. Okay, and we don't have any warnings. Okay, so sorry, it didn't do that long. Sorry. So that's all from me for this video, and I will come back in the next video. Well, as I said before, we'll try to do the syslog, not syslog, sysdig on the interrupt. But okay, see you later. Bye.